For decades, interacting with a computer meant waiting for a blinking cursor. You typed a command, and the machine patiently waited to respond. But in May 2026, that passive relationship shattered. Up until now, artificial intelligence has essentially operated as a brain in a jar. Engineers built models capable of passing the bar exam or writing complex software, but the systems were physically paralyzed. They couldn't reach out and affect the real world. This trapped intelligence suffered from 3 specific limitations. It had 0 long-term memory, 0 physical mobility, and it was choked by massive energy and network constraints. Then, over a single 24-hour period on May 8th, seemingly isolated breakthroughs cracked all 3 bottlenecks simultaneously. Engineers didn't push a standard software update. They began connecting the discrete layers of a fully autonomous digital anatomy. The foundation of this new stack requires raw, brute force computing power. The demands are growing so fast that they are literally outstripping the capacity of the traditional power grid. To secure the necessary energy, Elon Musk dissolved xAI, rolling its model asset portfolio directly into his aerospace company to form a new division, SpaceX AI. This new entity immediately structured an agreement with Anthropic. They are unlocking access to the Colossus One supercomputer, a facility packing 220,000 GPUs running on over 300 megawatts of power. The ultimate engineering objective here is to push these massive, heat-generating data centers entirely into near-Earth orbit. But clustering hundreds of thousands of processors together creates a massive traffic jam. Previously, without highly specialized hardware, the network would constantly choke and crash. To solve this, a coalition of heavyweights, OpenAI, AMD, Broadcom, Intel, Microsoft, and NVIDIA, released an open-source protocol called MRC, or Multipath Reliable Connection. Instead of relying on an expensive proprietary InfiniBand monopoly, MRC splits a single transmission across hundreds of parallel paths on standard Ethernet. If a cable fails, the data instantly routes around the hardware fault in microseconds, allowing clusters of 100,000 GPUs to operate continuously. With the hardware and network layers optimized, these systems secure the unchoked energy pipeline they need to stop pausing between user prompts and start running in the background. But infinite compute is useless if the system forgets who you are the moment you close the browser window. A true agent needs a continuous memory. Anthropic addressed this by introducing a feature called dreaming for their managed agents. It is a direct mechanical replica of human sleep cycles, applied to artificial neural networks. When the system sits idle, it automatically reviews past sessions. It merges repeated information, prunes outdated facts, and extracts macro patterns. For enterprise clients like the legal AI firm Harvey, this automated subconscious processing boosted real-world task success rates by up to 600%. Once an agent can remember the past, it has to learn how to manipulate the future. To test complex social strategy, Google DeepMind turned to the gaming industry. They acquired a stake in the studio behind EVE Online, setting up isolated offline servers of the notoriously brutal multiplayer space economy as a sandbox for artificial general intelligence. Inside this simulation, models are forced to practice long-horizon planning. They have to form alliances, execute complex deceptions, and absorb temporary economic losses to secure a strategic advantage years down the line in a highly dynamic society. Text prediction has evolved into active strategy. These systems are synthesizing internal memories and practicing long-term survival in hostile social environments. That brings us to the top of the stack. To be fully autonomous, all of that raw cognition and memory has to translate into direct physical action. In the physical world, the robotics startup Genesis AI released their Gen 26.5 foundation model, officially crossing the uncanny valley of fine motor skills. By learning from thousands of hours of human demonstration, their machines are now executing dynamic, unscripted movements. They can crack an egg with one hand, slice a tomato, and organize delicate wire harnesses, overcoming the spatial challenges that have historically paralyzed industrial robots. This physical embodiment extends directly into our software. Agents are natively taking over our operating systems. Models like Dubao's Seed 2.0 Lite and Alibaba's Qwen PC are utilizing omni-modal processing to see and hear your screen. Without waiting for a prompt, they can autonomously navigate across multiple apps, listen to a meeting, and organize a spreadsheet in the background. The intelligence trapped in the jar has successfully grown hands, metallic ones for the factory floor, and digital ones for your personal computer. The agentic interface has officially displaced the static grid of icons. The software no longer waits, it anticipates. You will no longer open an application and click through menus to complete a workflow. Instead, you will delegate entire project lifecycles to autonomous digital workers who handle the execution on their own. With Genesis AI taking over the factory floor and Codex managing the digital desktop, the cost of specialized technical execution is approaching zero. When a single person can orchestrate 1,000 autonomous workers across multiple project lifecycles, the traditional work week spent on discrete, repetitive tasks begins to dissolve. Economic value is shifting from the ability to execute a process to the ability to manage the network that performs it. We spent the last 40 years acting as the operators and typists for our machines. Going forward, our only job is to